All right, guys, here's the ed puzzle for section 4.2. We're going to talk about reflections here, and I know you guys probably know what a reflection is, but we're going to go ahead and define it, and then we're also going to go over the properties of a reflection, which you probably don't know. So just the definition, a reflection is a geometric transformation okay, so we're changing it, in which each point of the pre-image, and remember the pre-image is what we start with, has its image that is the same distance from the line of reflection, but on the opposite side. Okay, so it's the same distance from the line of reflection, but it's flipped over and now it's on the other side of it. And then the line of reflection is just the line in which the geometric figure is reflected over. All right, guys, so there's two properties of reflections that you have to know. Okay, so the one is that the pre-image, I'm just going to put PI, and the image are the same distance from the line of reflection. So if you look here, this is the same as this. So from here to here, that's the same as from here to here. That will always be true. That's one of the two things of the line of reflection. Okay, the second is that if P prime is drawn, so if we connect those, the line of reflection is perpendicular to P prime. Okay, so if I erase this, all I'm saying is that if we connect P to P prime, okay, that is going to be perpendicular to the line of reflection. Okay, always. All right, guys, let's go ahead and look at this. Now, I've already plotted my points and labeled them A, B, C. Go ahead and do that on your end. But we're going to do two different things. So, first thing we're going to do is we want to reflect it over the line x equals 3. Now, in order to reflect it over the line x equals 3, you have to know what x equals 3 looks like. So remember when you're talking about x, it's going to intersect the axis where x is equal to 3. So, oops, sorry, that's not a very straight line. This is the line x equals 3. That should be straight up and down, guys. All right, so when I do this, that means that A prime has to be on this side, B prime has to be on this side, C prime has to be on this side, and they're going to be perpendicular from this, okay? Well, perpendicular from straight up and down is straight side to side. So A is 1, 2 units, so A prime is going to be 1, 2 more on the opposite side, so that'd be A prime, okay? Your B prime is 1, 2 units, so it's going to be 1, 2 units over here. And then your C prime is just 1, so we're going to be right here. And so if we connect the dots, that's what you will have. Okay, now notice, and you don't have to do this, I'm just going to show you. If you connect A to A prime, that's going to be a 90-degree angle. B to B prime, that's going to be a 90-degree angle. C to C prime, that's going to be a 90-degree angle. So anywhere you go, that is a 90-degree angle. All right, I'm going to erase this, and I'm going to plot my original ABC so we could have a clean slate. All right, so I'm back at my triangle ABC. Sorry, straight lines on this board or on this tablet's a little hard, but that's the best you're going to get for now. So now we're going to reflect it over the line y equals 1. Okay, so you have to ask yourself, what does the line y equals 1 look like? Well, it intersects the y-axis where y equals 1. So this would be the line y equals 1. And this is my line of reflection. Now, something important to note, that if a dot or if a point is on the line of reflection, it stays there. It doesn't move. It can't go on the opposite side because remember, it has to be equidistant from that side. So this point here is also going to be C prime. Now, if you have something like this on a quiz or a test, do make sure you write C prime next to it so I know that you didn't just forget it. Okay, well, this line is left and right, so I'm going to go straight up and down. So my A is right here, and it's 1, 2 from it, so I'm going to go 1, 2 below it. So here's my A prime. My B is 1 above it. I'm going to go 1 below it. Here's my B prime. So here's my new triangle. All right, guys, so here's some very, very, very important rules to know. X and Y you could probably figure out on your own just because it's left, right, up, down. But these two, you're really going to want to make a note to memorize these because they won't be provided for you on the test. So really make a note to know these. Okay, so if we reflect a line over the y equals x, remember the line y equals x, if this is my coordinate axis, this would be the line y equals x, right? It'd have like 1, 1 on it, it'd have 2, 2 on it, it'd have 3, 3, my y equals my x. Okay, so that'd be line y equals x. And then this line right here would be the line y equals negative x. So this would be like negative 5, 5, negative 3, 3, so on and so forth. So please do note these rules and memorize them, and we will go over how you use them. All right, guys, let's look at example 2. So we're going to take FG, which as you've noticed I've already plotted, given these coordinates here, and its image after reflection over the line y equals x. Now I've kind of made the dotted line there to show you where y equals x looks like. Now, this is a little bit harder to see and a little bit harder to visualize by just reflecting it over the line like we did when it was straight horizontal or straight vertical. So I'm going to use one of the rules. So in the slide before where we had rules, I have AB is reflected over the line y equals x, it goes to BA. So I'm just going to write that here. So I have AB goes to BA when it's reflected over the line y equals x. Now notice all I did is I changed the order, okay? So my pre-image is negative 1, 2, and G is 1, 2, okay? So what that means is now I'm going to write my image. So I have an F prime and a G prime, and my AB goes to BA. So see how all I did is I flipped these to get this? So that's all I'm going to do here. I'm going to flip these. So it'd be 2, negative 1. And if I flip these, it'd be 2, 1. So I'm going to change this to red. Sorry, guys. So if I plot this now, and guys, it's so much easier to find the coordinates and then plot it on here than to just try to plot it. Okay, so my G is 1. Oh, sorry. My F prime, sorry, is 2, negative 1. I thought I screwed up. So 2, negative 1. There's my F prime. And my G prime is 2, 1. Okay, so I'd have it like this. Now, some of you are looking at this thinking, how is that a reflection? Well, let's look. If I were to draw a line from G to G prime, this would be a 90-degree angle. And if I draw a line from F to F prime, this would be a 90-degree angle as well. And also, this distance here is the same as this distance. And then this distance is the same as this distance. So sure enough, there's my two rules that follow when I have a reflection. All right, now on this one, I accidentally cut off the coordinates of triangle JKL. So I'm just going to write J is 2, 1, K is 5, 3, L is negative 1, negative 4. Now I'm going to pause this, and I want you to go through and do A through D. So all of these are basically utilizing those rules that's right here. Okay, so utilize those rules. So all I need you to do is find the coordinates of J prime, K prime, and L prime. You don't have to plot it, just find the coordinates, and then you can check it against mine. All right, guys, so here is what you should have got for the answers. So here in black, all I did is I copied those down from those rules. Okay, so when we reflect over the x-axis, all we're doing is making our y-coordinate the opposite. So if it's positive, it goes to a negative. In here, we have a -4, so a -4 would just be a +4. So the sign changes on the y, and that's it. When we reflect over the y-axis, only the x changes signs. So that's what I did on B. Reflection y equals x, I just flip the a and b like I did in the previous example. And then y equals -x, I flip the a and the b, and I make them both negative. Okay, so once again, if it's already a negative, that means it's a positive. So this is what you should have gotten. So take a minute and check yourself. And if you got it wrong, that's okay, correct it, but try to understand why you got it wrong. All right, so we do have a vocab word in here, and it's a glide reflection. So a glide reflection is just a transformation that involves a translation followed by a reflection. So it's a composition, okay? And this tells us that all reflections are rigid motion, so they don't change the size or shape or whatever. All right, so here's an example of a glide reflection. All right, so I've already plotted these 2 points. Now I'm going to translate it. Remember, this means left 12. And when this doesn't have anything, or if it's plus or minus 0, this just means doesn't move. So it doesn't move up or down. Okay, doesn't go up or down. So all I'm going to do is go these 12. I don't know if I have room. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's somewhere around here. Here's my A prime. B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And C, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's my C prime. So this is what I would get after the translation. Okay, then I'm going to flip and I'm going to reflect it over the x-axis. Okay, so the x-axis is just right here. Okay, I don't really need my rules when I do these. So this is 1 above, it's going to go 1 below. So here's my C double prime. And if I'm 1, 2, 3 above, I'm going to go 1, 2, 3 below. This is my B double prime. And my A is 2 above, so I'm going to go 2 below. And then here is my new triangle. All right, so I want you to try to do this one on your own. So plot it, translate, reflect it, and then I want you to try to answer this question down below, and we will go over it. All right, so as you noticed, I'm sure, this was the same example as before, but we just added this bottom part. So right here in gray is what we had before. Now it wants to know, how do we go back to what we originally did? So the first thing we'd do is we'd have to translate it right 12, since we translated it left 12 first. And then we don't change the y. And then once again, when we did that, I'd get this black triangle here, and then we'd reflect it over the x-axis. So this down here is what you should have gotten. All right, line of symmetry. Now you see these objects, and I'll ask, does it have a line of symmetry? So it's just an imaginary line through a shape in which if you folded it in half, it would lay on top of each other. So it says a line of reflection is a line of symmetry. So it's symmetric about that line of reflection. Okay, so I'll do this one with you. So if we folded it over here, the right-hand side would lay on the left-hand side. And if we folded it here, the top part would directly lay on the bottom part. Okay, diagonals wouldn't work. So what I want you to do for B and C is try to do these 2 on your own, and then we'll go over them. All right, so the first one had 2 like we did together. This one actually has 6, and this one only has 1. So let's look at this one together, because you may have forgotten it. If we fold it in line down the centers, the right would map over to the left. Okay, well, let's erase that. And let's say if we folded it from crease to crease, it would map over onto each other. So for every corner to corner would be 1, Sorry guys, these are really not straight. And then every center to center would be another one, meaning that there would be